Hello everyone, good afternoon, dear authors and invited guests. This is the technical session 3D and myself Richa, and this session will be moderated by me. And on the behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Competitive Strategies. I hope this session was informative enough for you, and in this session, we have eight presentation. Each presentation will be allocate 8 minutes for presentation and 2 minutes for question answer. After 7 minutes, I will raise a gentle reminder to conclude our presentation. And in this session, I kindly request to all participants kindly stay connected till the closing remark, so we can take a one quick snapshot, so making this virtual conference more memorable. And in this session, if you have any query and any update regarding your presentation, kindly write it to me in chat box. Chat box is open to everyone. And now I would like to start to introduce our chair of this session. Professor Nilesh Sable, sir. Dr. Nilesh Sable has overall 15 years of academic experience, presently working as SPPU approved associate professor in a department of Information Technology, Vishwakarma Institute of Information Technology, Pune, India. He has done a PhD in a computer science and engineering from Kalinga University, Raipur, on a research problem statement study on relationship standard mining calculation in a data mining. He is a at PPU approved PhD research guide. He has published 50 plus paper in a national international conferences and journals. He had filed a published 14 patents and 3 copyrights. Welcome to you, sir.
Thank you, ma'am.
And now I would like to start with papers. I would like to call our first presenter to present her paper on a smart assistive device for the blind people. Paper presenter is B. Valamathi.
Ma'am, am I audible?
Yes, ma'am, you're audible.
Whether my screen is visible to you?
Yes, ma'am, yes, it's visible.
Good morning, all of you. Let me explain research work, smart assistive device for the blind people. The main objective is to detect obstacle for the blind people. Here we developed a smart assistive device. Another name for this smart assistive device is called smart shoes. It detects object, pothole, fire, or shock in front of the user. Once if they detect any kind of these things, means automatically buzzer will sound. Let me explain introduction about this research work. The mobility is the biggest issue for the blind people. In order to move around, they must rely on what others. It is very difficult for them to walk around in the world. The majority of the blind persons depend on others people for their activities. Even if they go for anything outside and all, no, they have to depend upon others. The only solution we had is a white can to help them, but this can does not help them to recognize big objects. It's still challenge for their safety. We can employ an aid like a can or a trained dog or electronic device. The smart device will aid them to survive easily in the today's fast world. In this work, no, we have used 5 hardware components. One is Arduino board, and second one is the ultrasonic sensor, and next one is a flame sensor, and third sensor is a shock sensor, and finally we used what buzzer. These are hardware components, and software is Arduino UNO software is used to implement the whole hardware process integrating with the system process. It's an open source software. Easily we can understand this software. In existing method, they detect only obstacles and they detect only no missions using what are smart shoes. but in the proposed method, it detects obstacle, as well as it detects what a pothole, and also it detects flame, and also shock. Shock is nothing but what here vibrations are implemented, which are essential for the blind people. So hardware components, already told you, we have used 5 hardware components. This is the Arduino board. I don't want to go in depth about these things and all. Here, this is Arduino board microcontroller we've used is what 80 mega 328p. It has 14 digital input output pins, and then it has what a USB connection, power jack in ICSP, that is the in-circuit serial programming. And next hardware component is ultrasonic sensor. This ultrasonic sensor will emit what ultrasonic waves. So if any object is there, means automatically this original way it will travel from where this ultrasonic sensor to where object. If any object is there, means we'll get what a reflected wave. This ultrasonic sensor will receive what the reflected wave. Okay. So here in this ultrasonic sensor, no, it has what 4 terminals. One is a 5 volt, another one is what a ground. Apart from that, we have another 2 pins called what a trigger and then echo. Here trigger, no, this is also connected to these 2 pins are connected to where Arduino board. And this sensor, what the name is what HCSR04 sensor, we have used it. It uses what a sonar, that is ultrasonic waves, sound waves it will generate to determine the distance of objects using ultrasonic waves. These ultrasonic waves reflect off what a glass or a liquid surface and any transparent objects, even though the object has what a dust on it. Here, these sensors no can also detect what a complex shaped objects like what springs and all. And this sensor is connected to where the Arduino no. Already I told you it will transmit what ultrasonic wave signals, and then no, it will receive what reflected waves also. If there is any pitfalls, means it detect by using what ultrasonic sensors. Here range reduction is 2 centimeter to where 400 centimeters. That is 1 inch to where 13 feet. Okay. Here this operation is not affected by what sunlight or any black material. It comes completely with ultrasonic water transmitter and receiver model. Transmitter model will emit what ultrasonic waves, and receiver model no, it will receive what reflected wave. Okay. And third one is a flame sensor. This flame sensor is the most sensitive to the normal light. It is used to detect what a fire. Range is what 3 feet. This IR infrared flame sensor, here we have used it. It's very sensitive to where IR wavelength at what 760 nm to 1100 nm light. Here, no, when you move a flame source with infrared foot of what this IR sensor means automatically light will be here. If you see in this figure, automatically, light source, if you are bringing to this is IR flame sensor, automatically, LED will light up and buzzer will make what a sound. Again, it has what 4 pins, VCC, A0 and D0 and ground. This VCC is connected where plus 5 volt for analog, and for digital 3.3 volt we are giving, and A0 is for analog output and D0 is for digital output, and here GND is for what ground. And third hardware component is a shock sensor. This is the shock sensor we have used it. This shock sensor, no, another name for this shock sensor is called what a vibrating sensor. Okay, it will detect what a vibration. Okay, the sensor is connected to Arduino and buzzer. The output signal is done with buzzer. If there is any vibration, means automatically buzzer will make what a sound. And here we have used what last piezoelectric buzzer. We have used it with sound waves. Okay, so that's why here they will be given by applying electrical signal at high frequency. The crystal can make what a sound. And let me explain the flow chart of a smart assistive device for the blind people. Here, this in the shoe, no, we have embedded this sensors at the what is the board and everything. Here, sensor, no, 3 sensors we have used. One is ultrasonic sensor, flame sensor, shock sensor. This ultrasonic sensor, it will detect what 2 things. One is the obstacle as well as what pothole also. Okay. So once if they detect any obstacle and pothole, means it will activate what buzzer. Buzzer will generate what sound. And next one is what a flame sensor. If any fire, any high temperature things are there, means automatically flame sensor will be what it will sense it, and it will activate what a buzzer. Again, it will produce what a buzz sound, so that blind people know they should not go in that path. Okay. And third sensor is what a shock sensor. Here, shock sensor is for what a vibrating. It will detect what vibration. If it detects any vibration, means buzzer will be what produces what a sound. Okay. So this is what a diagram for what obstacle detection using what ultrasonic sensor. Ultrasonic sensor, it will detect what both the things. One is obstacle detection as well as what a pothole detection. Here, what is it? This is ultrasonic sensor. We have used it. When any obstacle is sensed near what ultrasonic sensor means, immediately the buzzer sound is what produced to the user. And this next diagram explains what a pothole detection using ultrasonic sensor. So already I told you in the what is the pothole detection? No, 2 centimeter to 400 centimeters it will detect. Okay, so that's why here if what is it? No pothole means you will get what no pothole, and then pothole is detected means it will give what how much centimeters what it's nearer to that blind person, and it will detect. Okay, so already I told you this is a minimum of what 2 centimeter to where 400 centimeter it will detect. And next one is flame detection using what a flame sensor. This flame sensor, no, it will detect only 3 feet away from the person. Okay, so here this is a symbol for what a flame. This is what is a electronic component flame sensor hardware component, and this is Arduino board. And then here we have what a buzzer. When any flame is detected 3 feet away from the person, then buzzer start what signaling using signaling the user about the flame. And last one is what a shock sensor. This is a shock sensor will detect what a shock. Okay, it's a sensor that will detect the vibration. Okay, so that's why here we have given it's a sensor that will be used to detect what vibration. When shock is detected, it signals what the user using what buzzer. And
Uh,
yes.
Ma'am, you have last 1 minute.
Okay. So conclusion, no, in the existing method already I've mentioned what is it? They detected only what moisture and what obstacles. In the proposed method, no, it detects what 5 things: obstacles, then pothole, flame detection, shock. These are all implemented that are essential for what blind people. Okay. In future work, no, we try to implement these 5 things plus what is the GSM thing. In GSM, no, we can keep what recorded voice, location tracking, text, SMS, and make these smart shoes even more comfortable and efficient to use it. Thank you.
Yes, ma'am.
Yes, sir.
Okay. Can for increasing the range of flame sensor, what we can do for increasing the range of flame sensor, because 3 feet is quite low,
Yes, sir.
right?
Yes, sir.
So,
Yes, sir.
it's considering the safety, if you are dealing with this safety of that blind people, so three
Yes, sir.
feet it
We
is
have to.
quite low.
Yes, sir. Actually, no, we thought of using what advanced flame sensor we have to use for increasing what distance. Sir.
Yeah. Minimum it should be near about 10 feet for getting
Yes,
the
sir.
safety of
Yes, sir.
particular. 3 feet
Yes, sir.
means it will catch a fire if
Yes, sir.
the person is using it.
Yes, sir.
Rather, can you precisely tell in one line that what extra things are provided in this? Because we are having something like smart sticks, right? Which are
Yes, sir. Yes, sir.
already present
Yes, sir.
in
Yes,
the
sir.
in that smart stick. Instead of a buzzer, as well as they are given some sort of vibrations vibrator,
Yes, sir.
so that they can make an alert to the user that something
Yes,
is
sir.
there, right?
Yes, sir.
So,
Yes, sir.
so what advances are there in the shoes which you
Sir,
have provided?
we pothole detection we have done, sir. Flame also flame detection we have done. Sensor all what is the flame
Pothole detection. It is by using what you have done. It code.
flame and then shock we have included, sir. Flame and shock.
Yeah, flame and shock. I got it. But pothole, how by using what you have detected the pothole? Which
So
type of
distance is
sensor?
there, no, sir. Sensor, no,
Okay,
sir. SW 10118 we've used it, sir. It will
Okay.
detect up to 300 centimeter. It will detect, sir.
Okay. Fine.
Yes. Yes, sir.
Okay. Thank you. And what in the future work you have precisely stated that the locations in GPS.
GSM module, sir. Now you told no, sir, increasing what a feet and all no for firing.
Hmm.
We'll include that one also in future works, sir.
Can you go back to previous slide, conclusion slide? Yeah. Okay. So here you have included like pothole detection and flame detection, shock detection.
Yes, sir.
Shock
Yes, sir.
detection is nothing but it will be useful for what?
Shock, sir. If any vibrating materials are there, anything is there, even what is the small electrical wires are there, no, sir. If they touch means automatically some vibration will be there. So
Okay.
with help of the shoe, no, we can detect it, sir.
Okay. Fine. Thank you.
Yes.
Thank you.
Thank you. Thank you very much, sir.
Thank you.
Thank you, sir.
Yeah.
Now we can call our next presenter to present her paper on a study of the neuro-learning model of diagnosis of the COVID-19. Paper presenter is S. Sivasakti.
Ma'am, just a minute, ma'am. I share my screen.
Sure, ma'am. Dear presenter, if you have any faces any issues, so we can arrange your presentation in last of this session.
Okay, I'm okay, ma'am.
So we can go move forward. So
Okay.
now we can call our next presenter to present her paper on behavioral finance, bibliometric analysis. Ankita Bhatia.
Hello. Good morning. Actually, Ankita is not available. She has gone for the convocation. So I am her guide and I will be presenting the paper. I hope that is okay. I am the co-author of this paper also.
Sure, ma'am. It's okay.
So I'll just share my screen. It says that you can't start sharing.
Yeah, now it's
Yeah, I'll start now. I hope my screen is visible now.
yes, ma'am. Yes.
Okay. So good morning, one and all present here. I'm Dr. Aarti Chandani. And this paper was written by all of us, which was primarily the research PhD topic of Dr. Ankita. And it was a sheer coincidence that she is getting a degree today. A convocation is happening right now, so she's not able to present. So we are talking about behavioral finance, and it's a bibliometric analysis. So the behavioral finance, as we know, it talks about how individual or investor behave while they are doing the investment activity. Now, this was not a very researched area until say 1980s. It has started gaining more importance only after 1980s or early 1990s. So when we talk about behavioral finance, right now a lot is being studied and researched about this. And this is more important in the Indian context because the studies which are undertaken are very less in the context of India. Now, similarly, the investment of retail investor of Indian retail investor is very low in the stock market when we talk about it, because the stock market is primarily driven and sort of controlled by the big investor, which could be FIIs or DIIs or even the mutual fund and others, but not much in terms of retail investors. So now when they are going to enter into the market, how the biases are going to affect them, behavioral biases, what we call them as, which is a part of the behavioral finance. So there was a theory which was proposed by earlier by Kahneman and Tversky, efficient market hypothesis, which was given by Markowitz. It was in early 1960s. And they mentioned that market price reflect all the information. That means the markets are perfectly efficient. So investor need not worry whether the stock price is overpriced or underpriced, and market reflect all the information. That was the theory proposed by Markowitz in 1963. While Kahneman and Tversky they actually went ahead and they said that this this theory is not market does not always reflect the correct price, and investors may not always behave rationally. So efficient market hypothesis was actually based on the fact that investors always behave rationally. So there is a big information gap which exists between the market and the retail investor. Now, all the information cannot or not necessarily gets transferred or depicted in the stock price. That was given by Melchiel and Pharma. And another in 1979, Kahneman and Tversky proposed the prospect theory. Now, this is one of the very important theory of the behavioral finance, which helps us to make a decision under uncertainty. And these decisions are primarily related to the investment decision. Then there was a herding bias. Now, there are multiple biases under behavioral finance. We talk about herding bias, we say loss aversion bias, we say that a prospect theory. There are many biases that investor actually exhibit. So why do they exhibit these type of biases? So these are some of the biases which are important. So the bias which actually, for example, as an investor, I follow what others are doing. So if market price of a particular stock is increasing because many investors are starting buying to, I also follow them. That is herding bias. So now there are different biases. We say that money measurement bias, accounting bias. So there are many biases which are related to investor behavior. So this is all about behavioral finance. So we did a bibliometric analysis and we identified the research from the Scopus database and try to find out the research paper which are published from 1979, because that's the important milestone when the prospect theory was given by Kahneman and Tversky in the year 1979. So for 40 years, we applied the 40-year filter and we identified the papers, and the key term which was used was behavioral finance. And then this was when we applied this filter in Scopus, we got 3,200 papers in that. But again, further sort of filter was applied. We used subject area, because subject area we had to use related to economics, because that's a part of the economics and finance. And then it further reduced to 1,629. And next filter English was applied, and which resulted in 1,612 articles which were used. Now, when we got this Excel, downloaded this Excel from Scopus, we used WAS Viewer as the software, which was used to perform the bibliometric analysis. So now, when we understand this, now if we see the papers,
Which software, ma'am? Which
WAS
software you
Viewer,
have
sir.
used?
WAS Viewer.
WAS Viewer. Okay.
Yes,
Okay.
sir. So now WAS Viewer was used. Now, if we can see here, in the year, there was no paper which was on behavioral finance before 2004. So now this shows the importance of the topic, that it has gained the momentum only in early 2000. Now, if we see that very less paper are here. Now, in 2012, from 11 to 12, see the number which has increased to 40. Earlier it was 2, and then 18, then 5, then again 40. And now this is where the topic has started gaining momentum. Now this is corroborated with this. Now, if we see the number of articles which are published, we see here the number of articles which are published here. Now, again, when we say that how, now A Star has only one publication in terms of behavioral finance in those year, which we have used from 1979 to 2019. The A category journal has 6 publication, and B and C, and there are certain other journal which are not ranked, they got 17 publication. So now we come to citation analysis. Now, in this particular citation analysis, what we have done, we have used a filter of India, because our context was that we wanted to understand how many authors are actually publishing in the area of behavioral finance when it comes to India, because in the subsequent slide, I'll show the authors are there from abroad, but what are the primary or the major contributor from India. So we see that only 114 Indian authors are doing their work in this particular area. And now we see that these are the 10 authors maybe 10, 11 authors who are actually published in the area of behavioral finance. So again, it shows the linkages, and these are the authors which are actually being cited. Now we say co-citation analysis. Now this is for the entire database, which includes the abroad also. So now if we see here, Kahneman and Tversky, as I mentioned earlier, they gave the prospect theory, and which is very important theory. So now how these authors are being cited, which means if Kahneman is being cited, Tversky is also being cited, or if Tversky is being cited, Thaler is being cited. Thaler again is a Nobel Prize winner who has given the nudging theory. Then Schiller is there. So these are the people who are actually sort of pioneers in the area of behavioral finance. So co-citation analysis shows us that if somebody is citing Nofsinger, who is again working extensively in the area of behavioral finance, are they citing audience? So we have seen that there are two clusters. One is in green and another is in red. So bigger the node, it shows that that person is being cited more times, and then these linkages which are being shown, that these are being cited together. For example, if this line is there, so Kahneman and Tversky are being cited together a lot. Now if we see, the Tversky and Subramaniam are not being cited together. That is what this particular analysis tells us. Then moving to this co-occurrence analysis, now this is very helpful in terms of understanding the research gap. Now, behavioral finance was our primary area of selection tool here. Now, when behavioral finance, again, it shows that bigger the node, because that was our topic. Now, how this particular topic is related to other areas which are being used as the keywords in that particular research paper. So now behavioral finance is being used again with CAPM model, which is capital asset pricing model. It is being used with the psychological biases or investment behavior. So it shows us that these are the areas where this particular topic is being studied. Now, if we say behavioral finance and prospect theory are not directly linked, that means when it is being studied, behavioral finance and prospect theory is not being used. Behavioral finance is being used with personal finance, financial planning, or investment behavior. So this helps us in understanding what are the different areas where we can actually do more research. This particular co-occurrence analysis tells us. So that is what was our study. Now, when we studied this, now, as I mentioned right in the beginning, that we are studying this from the 40 year. So we had a paper from 1979 to 2019, and we have understood that what are the research gap which are existing. With the help of the was fewer analysis, we did the citation analysis, co-citation analysis. And again, based on this, we say that financial literacy, psychological biases, and investment decision making are again the areas which can actually export in terms of doing more research. Now, some of the limitation, now this study was limited to the articles which are indexed or published in the journal, which are indexed in Scopus. Now, there are other databases like Web of Science also. We did not use that. I mean, that could be considered as one of the limitation. However, we know Scopus is much more preferred in terms of management sciences. And it gives us basically the research gap in the area of behavioral finance. And we using this paper, actually this was our paper of Dr. Ankita, which gave us insight that robo advisory is not much used. That is now in the investment automated investment advice services, which is robo advisory services, has come in sort of in wealth management study, which gave us a lead, and she concluded her PhD in the area of behavioral finance and how robo advisory can help in mitigating those biases of the investors. So actually this was a primary study which gave us a clue that robo advisory can be included. So similarly, there are many other studies, I mean, which topics which can be explored, and these are some of the references which we have used. And definitely in terms of the limitation, the size of the paper and what we could limit was one of the limitation. So I think that's all from my side. I'm open to questions.
What sort of recommendations you can do or you have done through this research study?
So the recommendation of this particular type of study is only that to identify the gap, and it recommends that the future researchers who are working in the area of finance or behavioral finance can undertake the research in those areas where the research is not done. So that is what is the major recommendation of this.
Okay. Okay, fine. Can you go to conclusion slide?
Sure, sir. Just a second. I hope it is visible.
Yeah.
Yes, sir.
This what is this PEAD, impact of behavioral and post earning announcement drift? What it is impacted basically?
Sir,
What your kind?
yeah. So again, these are some of the areas what happens when the company gives Q1 result, Q2 result, or they announce some sort of bonuses or dividend. So that is the time, how does the investor behave? So impact of biases on that particular aspect. How do I react if the Q1 profit is not as per expectation? What is my take on the particular stock? Do I keep, do I sell, or do I buy more? So that is where this can be used.
Okay, fine. Thank you.
Any other question?
No, thank you.
Thank you.
Now we can call our next presenter to present her paper on empirical analysis of effect of higher order harmonic on guitar chords classification. The paper presenter is Swati Sharma.
Yes, thank you, ma'am, for the introduction. Good morning to everyone. Let me share my screen. Is the screen visible, ma'am?
Yes.
Okay. Good morning, sir, and good morning, ma'am. I'm Dr. Swati Sharma, working as Associate Professor, Computer Science Department in Presidency University, Bangalore. I've written this paper along with Mr. Nipun Sharma. He is also working as professor in EC Department, Presidency University, Bangalore. So the title of our paper is Empirical Analysis of Effect of Higher Order Harmonics on Guitar Chord Classification. So in this paper, for today's presentation, I would be covering these topics. I'd be talking about the abstract of the paper, then what precisely are the contributions made by this paper, what are the harmonics in guitar chords, what is the methodology that we have followed to arrive at the results. Then briefly, I'll discuss my results, which we have obtained, followed by conclusion and the references. So the abstract of the paper and the research work is something like this. It basically talks about the music notes classification because it is gathering exponential traction in the area of machine learning. Basically, guitar chords and piano chords classification has given thrust to research in this area. So talking about the theory, a chord is a collection of multiple notes played together, and if viewed mathematically, it is a collection of frequencies. So I'll talk about this in the subsequent slide. To view these frequency components, numerous tools are available in SciPy Python library. Analysis of these harmonics reveal that they can be used as features to classify chord types. However, inclusion of all the harmonics as features in the classification problem does not necessarily mean that it would go on and increase the efficiency of the model in terms of its prediction accuracy. Basically, what I'm trying to tell here is this is a general notion that as more and more features we will include in our machine learning model, it will probably increase the accuracy or the performance of the model. what we have been trying to, we have tried to prove here is it is not necessary to include all the features to train the machine learning model, because it will come with the other implications, which I will discuss shortly. So on the contrary, it may lead to increase in dimensionality and cause additional burden on the machine to learn and prompt need for dimensionality reduction. Because anyways, the real data that we capture for to be fed to a machine learning algorithm is already having high dimensions. So dimensionality reduction is another challenge. So I'll be talking about that here. Therefore, the selection of optimal number of features becomes important. And in this paper, we are evaluating the effect of higher order harmonics on the model's efficiency. So whether the harmonics, inclusion of harmonics are increasing the efficiency of the model, or is it going in the opposite direction? So the contributions of the paper precisely are listed here. The paper briefly reviews the most important fundamental techniques, that is PCP, which is pitch class profile, and chromogram. These are used in guitar chord recognition along with its improvements over time. And also the second contribution of the paper is that it presents the experimental results on a data set of major and minor guitar chords. So it basically implements feature engineering and dimensionality reduction of PCP and chromogram on guitar chord tonality classification problem. So these are going to be the contributions of the paper. Now, before I move forward, I would like to discuss a brief idea about the harmonics in the guitar chords, because I understand everyone would not be aware of the basic music theory here. So this table here gives us a glimpse about the frequency distribution of harmonics for musical notes. Now, I would start from the scratch. Whenever we talk about music, there are the basic fundamental unit called notes. And if we are talking about Western music, we have 12 notes. So these 12 notes I have listed here in this table. So it is A sharp, B, C, C sharp, D, D sharp, E, F, F sharp, G, and G sharp. So these are the 12 notes in the Western music. This column here is giving us an information about the octaves. Now, whenever we hear a sound, it is basically a frequency, right? So when we play a music, let us say on any musical instrument, whether it's a guitar or a piano, if music is generated, it is another form of sound only. So when we talk about sound, it comes with the frequency variations. So similarly, if I'm playing a note, so the basic frequency of a note is 55 hertz. That means any sound which is generated at a frequency of 55 hertz is representing a note. But any sound at 55 hertz does not sound like a music. So what is the thing that making the playing of 55 hertz as a note sounds like a music? So I'll tell you this. We'll come to that. Now, if I go on, doubling this 55 hertz frequency here, basically we are moving to the higher octave. So 55 into 2 is 110 hertz. So 110 hertz means I have moved one octave higher. Further, if I double the frequency 110 hertz to 220 hertz here, I'm moving to one octave higher. So similarly, this is the highest octave that we have here, right? So starting from 55 hertz up to the this frequency of 7040 hertz, we have moved 8 octaves. Similarly, the basic fundamental frequency for A sharp is 58.3. Now, if you generate any sound of 55 hertz, it will not sound like a music. But if you play a note on a musical instrument, which is also 55 hertz, it sounds like a music. Why so? Let us explore this. Now, this is a general sound wave depiction which I have shown here. Now, if you see the first plot here, it is a sound wave in time domain with no zoom. And if you look at a plot just below this one, this plot, this is the same sound wave in time domain, but I have zoomed this out. So when we zoom this out, we look at this like this. These are the different variations that we see. Now, if the same sound wave is transformed into frequency domain, then this graph here shows the plot. So sound wave in frequency domain with no zoom. Now, if you focus on the fourth plot here, this is the sound wave in frequency domain, which is zoomed. Now, I would like you to focus here on the x-axis. If you see, this is the frequency, right? And if you notice, this sound wave is having a multiple frequency components, right? So these frequency components are available at different frequencies. So we can say that this component, this peak is available at 500 hertz. Similarly, the highest peak is we are getting somewhere around 300 hertz. So this is basically the sound wave analysis for the presence of harmonics. Now, what is a harmonic? Harmonic is nothing but the multiple frequency components which are present in a sound wave. Now, again, going back to my statement that a 55 hertz sound will not sound like a music. But when it
Sorry
is
to interrupt, ma'am. You have last 1 minute.
Okay, ma'am. So I'll come to the methodology. Methodology is what we have done is the experiment is performed on the data set with 859 chords classified as major and minor chords, which is processed via Python's pandas to form a data frame. Now, as the resultant data frame is including labeled targets here, this is the kind of supervised machine learning algorithm. So we have used 6 machine learning algorithms: linear regression, k nearest neighbors, support vector machine, Gaussian naive Bayes, decision tree classifier, and random forest classifier to classify this data set of 859 into major and minor chords. And time complexity of the proposed work, it is done on a 5-core machine with 16 GB RAM because the data set is not too large, 859 chords only. So these are the intervals between harmonics for major and minor chords with respect to harmonic 1. So here what we have noticed is that whenever we are playing a particular note on a musical instrument, it is accompanied by its harmonics. So not only 55 hertz, but the harmonics of 55 hertz are also generated, and harmonics are nothing but the integer multiples of the base frequency. So this is what we have analyzed, interval between 7 harmonics with respect to harmonic 1. The results that we have obtained, I have presented it in table 2. It shows that out of 6 machine learning algorithms that we have tested, 4 of them, namely linear regression, support vector machine, decision tree, and random forest, give peak performance when harmonic differences of only 7th harmonic are included. The performance never increased or decreased in case we included 8th, 9th, and beyond harmonics. So these results, accuracy score of 6 machine learning algorithms with different harmonic inclusions. So you see here, if we talk about linear regression, if I include only up to 4th harmonic, I get an accuracy of 0.57, 5th, 6th, 7. So with respect to every machine learning algorithm, the highest accuracy that we have obtained, I've highlighted it in red. So what we see here is that for all the 6 machine learning algorithms, the highest accuracy has been obtained up to 7th harmonic. So the misconception is that if we include higher harmonics, the machine learning algorithms will be improved in terms of performance, which is not so. On the contrary, we get an additional burden of high dimensions. And again, we have to deal with the dimensionality reduction techniques by using various techniques available. So the idea behind this research is that up to 7th harmonic, it is fine. And inclusion of the higher harmonics will only add a burden in terms of high dimensions to the machine learning algorithm. So this is the effect of higher order harmonics on classification algorithms. Here I have depicted all the 6 machine learning algorithms that I have tested. And you see here that we get the peak performance. So if we see it like this, yellow one is the support vector machine. So if you look at this yellow trend line here, we see that the highest accuracy we have obtained only up to 7th harmonic, which is 0.61. So after the inclusion, if you include 8th and 9th harmonics, the accuracy is showing a downtrend. So no need of inclusion of higher harmonics. That is what we have concluded. So the conclusion is basically the utilization of harmonic intervals of guitar chords is presented for the purpose of classification problem. Classification is whether the chord which is played is major chord or minor chord. And the paper clearly identifies that the classification accuracy of the guitar chord tonality does not increase when the higher order harmonics are included in the features list. All the machine learning algorithms peak at 7th harmonic inclusion only, and the higher order harmonics, 8th and above, can safely be excluded as features. Also, the inclusion of higher order harmonics also comes with the problem of missing values, right? So missing values will increase. So we'll have to deal with NaN values also. That is another feature engineering effort which would be required. So a concrete decision of their exclusion can help the data analyst speed up their workflow. The paper presents a novel way of utilizing the chords data for this observation that can be further explored also. So these are the references that I have used for the research. Thank you. And if any questions.
Thank you, ma'am. Can you go to the slide where you have mentioned all the algorithms which are used?
Yes, sir.
Yeah.
This one?
Yes, here it is. Yes. Basically, can you from the research whatever you have done, which algorithm you will recommend for the from this?
Yes, sir. Yes, sir. Surely I will recommend random forest classifier, because random forest classifier is giving me the highest accuracy of 93% here, sir. If you look at this random forest classifier, if I include only up to 4th harmonic, 91% accuracy I have obtained. 5th harmonic doesn't give me any improvement, but if I include 6th harmonic, I get 1% increase in my accuracy. So I tried including 7th harmonic, which further gave me an increase of 1% accuracy. Then I got greedy and I included 8th harmonic also. But with the inclusion of 8th harmonic, my accuracy started going down. So I conclude that random forest classifier is the best machine learning algorithm only if I include up to 7th harmonics.
Okay. Now this all are, I think, so supervised algorithms, right?
Yes, sir. Because my data set is labeled.
Okay, your data set is labeled.
Labeled.
Okay, fine. Thank you.
Can I ask a question?
Yes, sure.
Is it possible to implement a neural net in here?
Sorry, sir.
Is it possible to implement neural net in here? Neural network.
Surely, sir, that could be the future scope of this work. Basically, this has got a lot of future scope, sir, in terms of, because here we are dealing one with the machine learning algorithms. So improvement of machine learning algorithms can be done by including neural networks and deep networks also. Also, the hyperparameter tuning further can increase the accuracy. And with respect to music theory also, here I'm only classifying major and minor chords. So there are different chords, bar chords, power chords, 7th chord, triad chords. Those can
neural
also
networks can be done, sir. It can be done.
Can be done.
Yeah.
Okay. What about the parameter values you've used for these algorithms?
Sir, I've tried, yes, I've tried a little bit of hyperparameter tuning for all these 6 algorithms because there are different things. I can, if you want, I can show you the paper. But I have not gone much into hyperparameter tuning of individual. I have picked the default values because that was not the objective. So all the default parameters I've taken.
Okay.
Okay, fine. Thank you.
Yeah, thank you, sir.
Now I would like to call our next presenter, Siva Sakti, to present her paper on a study of the neuron learning model of a diagnosis of the COVID-19. Dear presenter, you may please start your presentation.
Yes, ma'am. Good morning to one and all. My topic is a study of the neural learning model to diagnosis of the COVID-19. Ma'am, is it visible, ma'am? And audio? Hello?
Yes, ma'am. Yes, it's visible.
This is my content. Introduction. The most general cause for large number of deaths in the world is COVID-19. Nowadays, the death rate COVID there is very increases because of the COVID. Many computer diagnosis CAD systems were developed to detect COVID disease in its early stage using lung CT images. I also take the X-ray images and I go to the X-ray images and CT images, but we got the better results in CT images, so we choose the CT images only. The curve systems mainly concentrate on identifying and detecting the lung nodules. There are many analyzing techniques using the deep learning algorithms to detect the presence of COVID-19, analyzing the CT lung imaging. So I use the and piece medication suggestions for early diagnosis was proposed within the workflow architecture and workflow.
Sorry to interrupt, ma'am. Your slides is not visible.
Wait, man. Ma'am, now,
Now it's visible.
excuse me. The characteristics of the medical images is X-ray is an image processing technique. Already we know that it contains a two-dimensional image, but the CT scan images having the three-dimensional images. So the both the technologies were same. X-rays has disadvantages of overlapped images, and the CT scan method has the benefit of resolved overlapping. This is my review of literature. In a review of literature, so I have the some advantages and disadvantages. Maximum advantages based upon the city images, um, because a synthesis approach based on a conditional generative adversarial network that can effectively generate high quality and realistic COVID-19 CT images for use in deep learning based medical imaging task for segmentation and classification. Mostly all of them having the advantages about the segmentation and classification. It could give the best accuracy. Disadvantages, it takes the time take more time, the time about calculating the accuracies only. Some of the papers mentioned algorithms didn't correctly give the results. These are my the literature review. My problem statement is the challenge of improving the prediction model to predict the COVID-19 disease for patients and providing timely response in predicting the disease. And timely response means we detect the disease in earlier stages, not go to the advanced stages. It will identify the in earlier stages. The earliest classification method consumes more memory for training images and reduces the classification performance. But the existing method have more time complexity for predict the disease or from the CT lung images. The objectives to predict the COVID-19 disease and performance in prediction using various classification techniques, and to improve the image segmentation and classification using the region density based cloning technique, to predict the risk of COVID-19 disease using the CT lung image attributes, to build a prediction model using appropriate classification method, radial restricted Boltzmann deep learning model to improve the classification accuracy. Methodology in the diagnosis, from the diagnosis is first started from the images, then a predictive model to identify the radiological image is used. The sample images are then pre-processed and sent for the segmentation process. In the segmentation process, the segmenting the lung and cavity regions was done. After the lung and cavity regions are segmented from the sample images, some parameters are chosen to train the classifier. Lung segmentation is a process of segmenting the lungs from the chest CT scan image, and also we use the lung CT scan. Mainly, I use focus on the lung CT scan images. threshold value needs to be set for the comparison to find the pixel intensity for the lung area, the chest CT scan. Pixel classification, I use the pixel classification method, is an effective technique that accurates the categories of the data sets. And segmentation, we know that it's the best image processing technique that helps in dividing and group the similar pixels, simplifying the diagnosis and evaluations. Next is during the initial stage of the offset of COVID-19, I use the supervised learning algorithms are coupled with the CNN algorithms to execute binary and multi-class segmentation of the infected region. In the we segment the lung nodules, also find out the any other diseases in the lung. This is the summary of the imaging techniques used in the diagnosis of COVID-19. In segmentation modules, we using the data sets. I use the benchmark data sets away the first part. I am in the review part of my research. I using the benchmark data sets. Then first we give the data sets in the pre-processing method. Then we partitioning the data sets. Then using the trained model and custom model technique. Then we got the output. We evaluate the outputs using the F1 score, many of the deep learning methods. Now excuse me. Now.
Yes, ma'am, it's visible.
Yes. This is the methodology diagram. First, I using the CT images and the X-ray images. Maximum, I using the CT images. And next, in pre-process, we get the many parameters. It's a resizing the image in gray level scale images. Next, we use the meta-heuristic OL optimization and bio-inspired SWAM optimizations. Meta-heuristic OL optimizations for the future ensembling and bio-inspired SWAM optimization for the descriptive CN method. After that, we test the data and training the data. After we get the accepted results for the COVID-19 class medication suggestions, last we get the results about the accuracy. Expected deliverables is specificity, accuracy is the main expected deliverables. To identify the best classification model which can help the medicine in predicting the risk of COVID-19 disease using CT lung image attributes only. Diagnosis of the COVID-19 through the lung imaging with improvised accuracy and automated procedures. The conclusion. We already know that the COVID-19 is a dreadful pandemic that caused millions of lives and has made a major impact on the global economy. The zero knowledge of the disease, symptoms, treatments, and impact of the coronavirus COVID-19 was uncontrollable and spread across the globe rapidly. So the analysis of the quantifications of the medical imaging is a time-consuming process and cost expensive as well. So the image processing techniques are integrated with artificial intelligence algorithms to automate the predict more accurately than manual analysis. These are my references. Thank you.
Thank you, ma'am. What there are n number of research which are done on this analysis of COVID-19. So, what exactly is your contribution into this? What exactly is the unique feature that you have done?
So, just now I started my work, sir. I still now in the literature survey, sir. So I want to use the method. Now I started in the pre-processing only, sir.
Okay, but before pre-processing, you might have done some sort of literature survey, right? From that, you have been found some sort of what we can say a research area where you can put your contribution. So what exactly is that?
Exactly, that's find the COVID-19 in early stage and also the other diseases in lung. We got it, that, sir.
Okay, fine. Thank you.
Thank you.
Shivasakti, I have one suggestion for you, especially because you are beginning your research. Because you are using this artificial intelligence techniques for medical healthcare. These days, most of these algorithms are treated as a black box in the field of medical community. So there are some explainable AI concept which you can explore that
Okay.
would bring a lot of trustworthiness and interpretability of the model, because we just cannot take the results of ML or DL algorithms just like that in medical field.
Okay, sir.
So the patient or the clinicians, they need interpretability. Okay, why a particular CT scan has been classified as COVID-19? Why not? Or what, on what basis the classifier did this prediction? So for this reason, if you can include explainable AI concept in your research, especially because you're beginning, it will add a lot of value to your research. Okay, good luck.
Sure, sure. Thank you, sir. Thank you so much.
Now moving ahead, we can call our next presenter to present his paper on implementing fog computing architecture using AWS IoT Greengrass. A paper presenter is Ali Akbar Faiz.
Hello.
Hello. Dear presenter, you may please start your presentation.
Okay. Is my screen visible?
Yes.
Okay. So, hello, good morning, everyone. My name is Ali Akbar Faiz, and I'll be presenting on the topic implementing fog architecture using AWS Greengrass. And the co-authors are Dr. Digambar Pawar and Neha Kali. So these are the contents of my presentation. I'll start with the introduction, then move to the motivation and problem statement, then literature review, proposed work, results, conclusion, future works, and references. So what is fog computing? Fog computing is a paradigm that extends the cloud computing services to the edge of the network. Like cloud, fog also provides data, compute, storage, and app services to the end users. The advantages of fog computing over traditional cloud computing models are that there is less proximity to the end user and supports mobility. Then it supports the IoT applications. The motivation for the fog computing architecture lies in the real world scenarios like the smart grid and smart traffic control system and smart building. So AWS IoT Greengrass is an open source edge runtime cloud service. Following are the use cases of AWS Greengrass. Runs at the edge, manages apps, controls fleet, and processes locally. There are some limitations in AWS Greengrass, which is fog connectivity. So there is no method to connect the fogs in AWS Greengrass, and the mobility is in between the end devices is limited to only 8 fog nodes, and the system is less fault tolerance in case if the fog node occurs a failure. So the motivation lies in like as you can see, everything which we have around us might be having some sort of replacement in terms of like a smart device. Like in your room, there might be a AC or fridge or something else which might be having a smart device. So these devices are connected via internet, and they are growing exponentially, and they are producing a lot of data. So this will make performance and network congestion challenges at the edge of the network. So due to this, cloud only solutions are impractical for these cases. So our problem statement is that in fog computing, there will be always a trade-off between performance and security. So the following are the objectives which we are trying to accomplish directly and indirectly. First one is hiding the identity of the communicators, obtaining anonymity and communication effectiveness, and making the system fault tolerant, assisting mobility and authentication of nodes. So these are the papers which I have read. First one is open fog reference architecture, which is given by some major tech giants like Intel and Cisco, which is a fundamental documentation for interoperable uh, IoT devices in the fog computing architecture. The second one is a review on fog computing, which provides the current contributions in the research and the forthcoming changes in the IoT world. And the third one is fog computing and cloud computing, which is compared using CP-based real-time IoT applications. And the fourth one, in which they have discussed about a QS quadrosilio problem, and they have also given some solutions to eradicate it in the view of smart cities. So this is the generic fog architecture. As you can see on the top layer, there is cloud and cloud storage. And in the middle, there are the fog nodes. These are the fog nodes. And then on the ground layer, there are the end devices, which gets connected to the fog, not directly to the cloud server. So the important terminologies in this model are administrating subsystem, which is the backbone of the entire architecture. It runs in the clouds, and its main purpose is to provide all the functionalities of the cloud, and basically also provide some sort of authentication and authorization. So the patrons are the end devices which will be requesting for some things that they have to do. And then we have convergence points, which is a set of devices in the fog layer that can be logically conceived as a fog node. So if any request which is being done by the patrons, that can be satisfied by this convergence point. And then we have the implied assembly, which is nothing but a small region in which the patrons are present. There is no explicit physical boundary or geographic area to define it. So this is the AWS Greengrass architecture. We have this cloud, and then in the middle layer, similar to the fog architecture, we have IoT Greengrass core, and then devices can get connected to this AWS IoT Greengrass core. Any device which is using this Amazon free RTOS or AWS device IoT SDK can interact with the Greengrass core.
Dear presenter, you have last 1 minute.
Okay. Greengrass group is nothing but a collection of settings, components such as devices and subscriptions. Groups are used to define the scope of interaction. For example, a group might represent a floor of a building, a traffic signal, or an entire mining site. So devices in AWS IoT Greengrass, there are only two types. One is a Greengrass core device, which is the fog node, and the other are the client devices, which gets connected to the Greengrass core to make request and get their request service. Then we have our proposed model can be mapped to the generic fog architecture in the following way. In the fog cloud layer, we have this AWS IoT core works in the top layer, which is the backbone of the architecture. If extra storage is required, we can use Amazon simple storage service. For the fog layer, we have the AWS Greengrass groups, which are used to organize the devices and settings and subscription. They are mainly defined to limit the scope of interaction. And in the ground layer, we have the devices which are the patrons basically, and they will be making requests. Then we have made a connector server to connect all the fog nodes, and we have used JSON web tokens for authorization. And the following are the routes which we have implemented for the connection of the fog nodes. One is a login message tokens and the reports. Each will be having some other functionality. And then we have connector scripts which are being run on the fog nodes. So the connector scripts run both on the connector devices, and it is used to connect to the connector server, and it will be running on the fog nodes. So I'll talk a little bit about the local communication, how it is done in the fog architecture. So first, the device will make a discovery request directly to the cloud. Then the cloud will send it the details of the nearest fog node which it can be getting connected to. And once the connection is made between the fog node and the client devices, then no further request will be made directly to the cloud, and each request may be satisfied directly here. And even local communication without the presence of internet is possible in this sort of architecture. So this is the entire architecture which is formed. On the top layer, we have the AWS cloud, and then in the middle layer, we have AWS Greengrass core device, which is the fog node, and we have implemented our connector script, which gets connected to the connector server. In this way, we are making a connection between the fog nodes, and here are the end devices which will be making requests to the fog.
So your contribution is just on connector, right? Rest all the services are taken from AWS itself. Go
Yes,
back
sir.
to previous slide. Yeah. So from this architecture, whatever you have shown, your contribution is what?
So this connection between the fog nodes.
Okay. What it benefits? Can you state any or three benefits of this? That was because without using this connector, you can't
Yes, sir.
achieve such benefits. Can you note that benefits?
Yes, sir. If end device is connected to this fog nodes, let's say, and then if suddenly it is moving and it needs to get connected to this one, so this fog node needs the information of all the next nodes, and if there is some sort of issue like a smart traffic control system in which some car is getting stolen, so this connect via this sort of communication, they can send information about the stolen car, and it can search in the nearby nodes.
Okay, fine. Thank you.
Okay, so this is the way we have established a subscription which will enable the communication between the devices. And this is how we have simulated a smart reader device, which will be a publisher, and a motorized store, which is a subscriber. And this is a client program which is sending temporary reports to the server. And we have also tried to look on the comparison how fog is giving very less response delay when compared to the cloud service, as you can see in milliseconds. So conclusion is that the proposed design and architecture, we have used the implementation using the AWS Greengrass, and we have discussed the challenges faced during the implementation of the fog system. And we can see that the fog computing architecture performs much better than the traditional cloud over method. Hence, these method can be used in time-sensitive processing. And for the future work, we are thinking about implementing TLS between the connector script and the connector server, and making the entire model more resilient from the attacks and the node failures. And we are also thinking about the implementing the blockchain architecture because it is decentralized. And
Yes, sir.
that is
Thank
all.
you. Can you differentiate how fog computing is different from cloud computing?
Sir, in the cloud only architecture, directly request is made to the cloud server. Suppose in our house we have Alexa devices, right? So if we are saying to the Alexa that please change the temperature to 24, let's say. So one request will be made to the cloud, and then cloud will instruct that device to set the temperature to 34. Okay, so this way there is a round trip time. But if we have, let's say, a smart pre-processor, like some sort of, and there is a communication, direct communication can be established between the request and the other device, between a subscriber and publisher. So this is a basic thing.
And how you have analyzed that your performance has been increased of fog computing?
Sir, I have sent a time. I have created a time like when I have sent the request and when it is getting received on the other device, and then I have taken the subtraction like that, and then I have made like 500 requests, and then I have seen how the performance degrades in the cloud only architecture, and if we are using this fog architecture, it is performing much better.
Okay, fine. Thank you.
Thank you.
Now, moving ahead, we can call our next presenter to present his paper on machine learning and a deep learning method for the detection of schizophrenia using magnetic resonance image and EEG signals, an overview of the recent advancements. A paper presenter is Nushat Saifi.
Thank you very much. I'll share my screen now. Okay, good morning, everyone. The paper is entitled The Machine Learning and Deep Learning Methods for the Detection of Schizophrenia using MRI and EEG signals. It is an overview of the recent advancements. Just a minute, one second. I'm sorry for this. Okay, so yeah, this is a collaborative work done in association with other professors from Nottingham Trent University, Dr. Mufti Mahmood and Dr. Muhammad Shamim Kaisar from University Dhaka in Bangladesh. The introduction to the problem is the schizophrenia is an umbrella term characterized by several mental disorders such as delusions and hallucinations, social withdrawal, loss of contact with reality, poor speech, loss of motivation. Now, this is according to World Schizophrenia Report, the definition we have taken. Now, according to US National Institute of Mental Health, about 1.1% of the world's population is affected by this, and about 3.5 million people in the US alone. There are innumerable cases that go unaccounted for due to the complexity of diagnosis and mainly the overlapping nature with other mental disorders. So there is no fixed, this is actually a heterogeneous in nature. There is no fixed symptoms or fixed disorder that characterizes schizophrenia. Often the symptoms or the issues the patient is going through is heterogeneous in nature. Often it overlaps with other psychiatric disorders. And it has no specific biomarkers for accurate diagnosis of this disease. So the motivation for this work is mainly because in the recent times, due to the advancement of the powerful machines, especially the GPUs, and certain algorithmic advancements in the field of artificial neural network, many ML and DL algorithms have been applied for complex medical data. And this was a huge task even a decade ago due to limiting computing abilities. In certain cases, what happened is ML and DL techniques have surpassed human level performances, but not necessarily in the field of medical science. So this was one of our main motivations, because huge number of papers have been proposed in the literature using AI techniques. Now, these high computing devices also contributed towards interpreting brain activities and their interconnectedness through different biomarkers. So this has led to the development of many new tools and techniques for the classification or prediction of schizophrenia disease. So this is a trend that we have taken from Google Trend, which says, the number of papers that has been published in the recent times, we can see here. In the last 2 years alone, the number of publication has surpassed what was published in the first decade of this century. So it shows the immense effort put by the research community towards prediction of schizophrenia. Okay, so the novelty of our work lies in the fact that there are many papers that have addressed review of schizophrenia, but for example, this paper actually does a review of Alzheimer's disease, Parkinson's disease, schizophrenia using DL techniques, but using only MRI. On the other hand, this paper takes ML techniques using MRI, and here DL using MRI and some other clinical data. And this paper addresses ML techniques using EEG. Our work differs from these surveys in the fact that it uses, or it includes ML and DL techniques using both modalities, MRI and EEG, both biomarkers. Okay, so this is to the best of our knowledge, first of its kind. We have followed the Prisma strategy to identify the relevant papers and do the necessary filtering to end up with around 200 papers for this study. To start with, we identified some of the popular data sets that are used in MRI and EEG paradigm, and these are some popular data sets that are used with a brief description. The point to be noted here is all these data sets are having a limited number of samples. I'll come to this pointer towards my end of my presentation. Just a minute. Just a minute. I'm sorry about this. Okay, and okay, so this is the table that lists out some of the ML techniques that has been applied for schizophrenia prediction. In the first column, we have mentioned here the references, followed by the data set that has been used for the study, and the corresponding ML algorithm that was used, and what is the accuracy, and some of the remarks that we have observed from these papers. We have done it separately for MRI and EEG for ML techniques. A similar thing we have done for the DL techniques also. So this table corresponds to deep learning algorithms. And what we have done finally what we have done is, like, we have identified the best performing algorithm from each of these categories, and what data set they have used, which algorithm they have used, and what accuracy they could achieve. So this is one brief representation of our efforts. Our observations is the issue of generalizability. For example, a research team that uses a data set that was prepared according to their instruments may not work well on a different data set collected from a different scenario. So this is one thing. Another thing is the small data set size, that as I showed you in previous slides, the number of samples taken is within 30 or 40 samples, which is very, I would say it is insignificant considering the deep learning algorithms that are being used. Although the research literature has made
it gives an
subjective
overfitting issue, right? If you are using it.
Yes, it also has that issue. Other than that is the researchers, they use augmentation techniques, which is not a correct way to do it, especially in terms of medical field, because the augmented data sets are just generated ones, by doing some little scaling and reflection and all those things, little bit rotation. So this does not accurately represent the actual medical data. So this is one issue that we observed. Most of the data sets that is available is basically for the two-way classification of healthy control and schizophrenia cases. It will be helpful to have a data set that can assist in differentiating schizophrenia from other mental disorders, especially because schizophrenia often overlaps with symptoms of other psychiatric problems. Yeah, as I said in the second point, this is actually a continuation. This will result in optimal treatment and betterment of the patient, and exactly identifying whether it is really a schizophrenia or it is it's the characteristics of other psychiatric disorder would help a lot. Okay, so here the work that we carried out is using Google Scholar, and the papers that we retrieved are not from fixed databases. So what we are actually currently doing is we are extending this work by adopting Kitchenham's guidelines. That this guideline actually has a lot of protocols, like what is the rationale behind the survey and what are the research questions that needs to be answered, and what is the selection criteria that one has to follow, especially doing such reviews, and what quality assessments that we are maintaining. All these things we are adapting, and currently actually we are in the process of collecting the papers from these databases, and in coming days we will have a comprehensive paper that addresses most of the recent research gaps that this field is having. Thank you so much. If you have any questions, please let me know.
See, precisely from the COVID-19, the data set, whatever is there for healthcare, it is the most demanding one, and it is the most valuable thing which we are having now, right?
Yes.
So
yes.
making the data set available is the major issue in case of this healthcare.
Yes, of course.
So if you want doing this, considering the databases from ACM, Springer, IEEE, and all that thing, it will not give that result which you can go for real time data collection, right?
No, I think here by database I meant retrieving the relevant papers from these databases, not the data set itself.
Okay.
Yeah.
Okay. Now, what if you want to work on this? What you have planned for regarding your data set?
No, my contribution is not going to be in the creation of data set. It is going to be reviewing the existing study, identifying the research gaps, what ML/DL algorithms have performed.
But for reviewing the current study also, if the data set which the previous author they have referred, if it is not up to that level, then how you can come to certain conclusion regarding that?
No, that we will identify as a research gap, right? This if the certain field doesn't have adequate data set, it is not the responsibility of the reviewer to provide the data set. We will only identify and point out the shortcomings.
You will give the remarks regarding that.
Yes, exactly.
Okay, fine. Thank you.
Thank you.
Now we can call our next presenter, to present his paper on N-gram-based legal parameters rival the state of the art and the future research trends of Indian judiciary. A paper presenter is Soranil Mandal.
Thank you, ma'am. Ma'am, am I audible?
Yes, you're audible.
Okay, thank you. My screen is visible?
Yes.
Yes.
Screen is visible.
Thank you for having me. Thank you to the ICTCS administration for accepting our paper. I am Shornin Mandal with my guide, Mr. Adash, assistant professor at Adams University. Our paper name is N-gram based legal parameters retrieval, the state of the art and the future research trends to the Indian judiciary. So this is a table of content which I will discuss in the paper. Let's talk about the introduction. So in natural language processing, there are lots of segments are there which help us to derive or pre-process the various documents, which after through that we can get the proper context of the document. So in such case, in our Indian judiciary system implementation, we use the natural processing techniques or tools through which we found the context of legal documents. In our case, we worked on dowry death domain. Now, dowry debt, we use the dowry debt segment. So that's why in our paper, we basically performed a bag of words bag of words techniques or count vector technique and term frequency and inverse document frequency technique through which not only we find out the specific legal terms in case of multiple legal documents, but also we can find out the specific and exact terms which define or make difference from multiple domains legal documents with the approach of N-gram analysis. So in our work, we found some relevant work which actually worked on N-gram based work. And this is the first work, and N-gram categorized helpful text classification. They are in this paper, they actually examined the effectiveness and characteristics of N-gram type N-gram, and they actually worked on multiple sentiment analysis to attribution, the domain analysis, and they worked on a very large number of parameters, which through that actually they worked on a HTML based processing system that from a HTML page, they extracted multiple datas based on any specific domains, which helps us to create the attribute. And another paper, we actually find out these two papers. This is our major paper, which is the advancement of this today's work. This is an approach of major extract parameter legal documents using text analysis. This paper is by me, Shajib Shah, and our guide. So this paper, we actually worked on 8 legal documents. And I mean, we can work on n number of legal documents due to the constant scenario. You worked on 8 legal documents, and through which we extract the unigram words, means single words from a dowry legal document after applying the applying the count vector method, and we created a proper framework using this method. So in this paper, we find out lots of disadvantage in our paper, like why don't we use the time frequency input document frequency, and we never use the concept of TF-IDF in this paper. And that's why in the second paper, this text analytic approach, exploratory visualization of legal parameters of dowry cases, this is our second paper. In this paper, we actually worked on count vectorization, and from the count vectorization procedure, we make a TF-IDF after time frequency inverse document frequency approach. So on the TF-IDF, we applied on a unigram basis word, but again the problem comes, which is that a unigram word doesn't express the context of a sentence, basically a corpus in case of a legal document. That's why we worked on our today's paper. So before explaining the today's proposed methodology, I started to give a little discussion on that. What is TF-IDF? So TF-IDF comes with the round frequency and inverse document frequency. What TF-IDF actually does, suppose you have a bag of words, you have multiple words are there, and from the words, there are, let's consider one word is intelligent, and other word is fool, and there are another word is fool, another word is dumb. So if I talk about the frequency of the words, if there is a word like fool in dumb, if these word frequency are more than a word intelligent, so that is that meaning that word dominance is same than the intelligent word intelligent with another word dumb? It is not. So why? So that's why that term frequency, inverse dominance frequency concept, what it concept express that lower the number of frequency, high is dominancy. So how it comes with of course the logarithm part. So number of sentence and number of sentence containing the words, this is the logarithm in segment parts. Based on this segment part, that dominancy of a word which has a so little in the entire document this scenario, so that how this word dominancy come. And let's consider today's word. So our word, so this is the third paper from the first to second advancement paper of this thing. This is the third paper, future work for the first two papers work. So in this paper, what we do, we actually take legal documents, specifically dowry related legal documents. It's an Indian dowry legal legal documents from Manupatra website, and it's the PDF documents are in there. So we have multiple 8 number of PDF we take. We can take n number of PDF, it's up to us. So on that PDF, we did the pre-processing technique. We did the pre-processing technique. We did in the pre-processing technique, we remove the header and footer of the PDF. We convert all the words in a lowercase. We remove the CRN, criminal record number. And then pre-processing technique, we remove the HTML tag, full name, stop words, digit symbol. And after doing so, we do the lemmatization and stemming technique. So what lemmatization does, if there is a word in a word third form, like going or went. So that lemmatization technique, word lemmatization technique, going to go, went to go. Okay, so it takes a verb first form. And we did after that, we applied the n-gram procedure. So n-gram is n equal to 1, n equal to 2. So in n-gram procedure, we applied the outer join. Why did we outer join? So we have first PDF. For first PDF, it's a list. First list consider data. First list consider all the tokens, and second list consider all the tokens. List means number of the PDF. I have 5 number of PDF, will be 5 list. So for first list, if n equal to 1, it give me the one word. If n equal to 2, it take the 2 words. So how n-gram works? Let's give you an example. Suppose this is my line, data frame consistency of n-gram word. So n-gram will, if n equal to words, and the word will be data frame, one word data frame, second word consists, third word of, fourth word n. But if n equal to 2, it will take data frame consist as a one word, consist of is a second word, of n is a third word, and so on and so forth. If n equal to 3, you need to take first 3 consecutive words. If n equal to n, the first n consecutive words. From that segment, we do the unigram word and bigram word. We made the 2 matrices or 2 data frames, and on that contrary, we use the count vectorization and TF-IDF technique. Let me show you the data result our work. So this is the unigram data frame. Unigram data frame. It is a unigram data frame. So here you can see our work is based on dowry domain. So you can see that this case 1, case 2, case 3 up to case 8, these are the PDF number. Okay, the number of PDF. If we take 10 number of PDF, it would be the PDF 10. So when we will do the extraction of the word from every last PDF, we can see that victim, that cruelty, suffer, burn, trial, these are the words which actually exist in the majority of the dowry cases. Okay, and the occurrence of frequency of this word exists in the majority of the cases. So you can see that 25, 12, 12, you can see the 7, 10. So these things actually express the context of the entire PDF document based on our work. So, and second case, we worked on the n equal to 2 segment. So where the two consecutive word exist in how many word? Because this word doesn't actually express the context of an actual sentence. How? Like example, that cruelty is a word, okay, but if someone put not cruelty, not word in front of the cruelty, so if that doesn't express that what it actually says, that because putting not in a putting not word in front of any actual word, it changes the it actually revert the meaning of the actual sentence. So that's why we actually worked on the n equal to 2 segment. So n equal to 2 n equal to 2. So here
Sorry to interrupt, dear presenter. You have last 1 minute.
n equal to 2 actually here is expressed the how many number of the bigram word exists in majority of the segments. So that's why in we actually make the frequency matrix based on our work, and that's come in this segment is the most important segment. So data visualization technique, where we mapped majority of the words in case of heat map, because from the heat map there is a problem is that we cannot find out how two words are related to each other based on the word. That's why we work on the dendrogram analysis. And the dendrogram analysis, we actually found out that majority of the two words are actually related to each other. Based on that two words, another words is related to each other, and that's how actually understanding of a PDF document can be understandable for a practitioners or a legal reviewer, so they can actually extract the words from the legal documents, so which actually help them to understand the meaning of the context of meaning or context of the legal domain. And not only it will help to the regular legal practitioners or people or judges or lawyers, not but also to help the regular people who actually don't understand the major of the legal terms in case of legal documents. So that's why in our conclusion, yes, visualization helps meaningful understanding information, and it will help the legal professional to understand the dominant words present in the legal document, and the weighted mean and count vectors helps to displace the majority of the word. So if you have the limitations of the work, so there are two data frames we have, unigram data frame and bigram data frame. But the question is which one is better and why it is be considered. So this is the important thing, because we cannot work on two data frames at the same time. So we have to choose one data frame. And if we choose one data frame, we have to consider why it is better. And based on that, we need to understand that how to create a data frame, data set from the legal document, because in Indian legal document there is no data set exist still now. Data set basically based on text classification related data set, like there is a line, based on the line context of the text line would be there. So our main approach is actually to create a data set. So that's why in our future work we will work on the dominancy between the unigram bigram, which word we need to take from unigram and bigram. And if we choose the bigram, all the tokens, so among all the bigram tokens, which are the major bigram tokens we need to choose from all the bigram tokens. And end of the day, we want to create actually a data set based on dowry related data. And through that, we will want to do machine learning and neural network approach on our data set, so that it will help any legal professionals or any novice user to find out how to create or how to understand a legal data set. Or if I give an input of a corpus of course legal data, so what would be the context will become based on corpus data. And this is the reference we take. And at last, I would like to thank Tona ma'am, our assistant professor in development computer science sub-engineering for Adams University, for our support and encouragement of the guidance. And we are like to thank them on the website for our website. And thank you. So if there is any question, please ask me.
Regarding, can you tell me, have you analysis in this case regarding as you are using n-grams, precision recall terms, have you analyzed somewhere?
So precision recall terms comes with a machine learning approach. We don't go for machine learning yet. This is the part where
it is proposed one.
create. No, this is the machine learning works come when we apply the machine learning algorithm we didn't apply in machine learning algorithm. Our data set will be created from either bigram words or unigram words, which will be better. And after, if we find out, let's consider bigram is better. So among that 11 words, we need to find out which 11 from all 11 words, which word is more dominant. So based on that word, we need to create our data set. On the data set, we will apply ML or ANN, and based on that, we need to find out either we need to do.
So that is your future scope to applying.
Yes, that is our future scope. Yes.
Okay, fine. Thank you.
Thank you.
Now we can call our last presenter to present his paper on performance evaluation of CNN models for face detection and recognition with mask. Paper presenter is Prashant Kumar.
Yeah, I am audible.
Yes.
1 second. Is it my screen visible?
Not yet.
1 second. So is it visible now?
Yes, it's visible.
Yes. So, hi, good morning all. Today I present here to present my paper, Performance Evaluation of CNN Model for Face Detection and Recognition with Mask. And my paper ID is 296, and my co-authors are Sujata C, Padmsri Desai, and Pooja. And the agendas of today's project is, first we will discuss about the introduction, literature survey, database and dataset details, framework for the face mask detection, results for face mask detection, evaluation matrix, comparison of the different model for face mask detection, framework for face recognition, result for face recognition, pipeline for the mask face recognition, result for mask face recognition, result analysis for masked face recognition, conclusion, future scope, and the references. So now we will see about the introduction. So in recent times, where COVID-19 has an impact on manufacturing, travel, tourism, hospitality, and crippling the global economy. So in addition to it also, the growth curve of the human death across all the globe due to this pandemic has increased. So this paper relies on the computer vision and the deep learning, intends to see that make an impact and solve the real world problem of the safety measurement. So in this paper, we propose using this framework, we can detect the people wearing mask or not, and after that we can recognize the person and authenticate accurately. So this would help in increasing the safety measure. So our contributions are, we have built a non-masked and the masked data set for the face recognition, and we proposed a framework using the deep learning model for the face detection and recognition the person with the mask on the face, and we have compared the different model for the face mask detection and achieved 98% accuracy for inception V3 and demonstrated the result on our data set with accuracy of 88% for face recognition with mask. And these are the some of the literature survey, and I will not go in so much of details because it will take a lot of time. So the literature survey which I was done on the retina face mask, a face mask detector, and the face recognition system using the FaceNet algorithm for the employee presence, and the masked face recognition using the convolutional neural network, and the detecting masked faces in the wild CNNs. So these are the mainly 4 papers which we have taken as a improvement for this project. Now we will see about the data set. So we have generated our own custom data set. So our data set consists of 2520 images, which is of 42 peoples, and with mask people is to 1000, with mask 1260 images are there, and without mask 1260 images there. And we have done some data pre-processing. So the bounding box annotations are put for the every images using the bounding box tool, and using the converting the tools of the class of image class also added. And finally the text files are also generated for the bounding box, because we have used the YOLO V4 model as one of the experiments. So their bounding box is text file as required, so I have made that. And these are the some of the sample data sets which we have created. And now we will see about the framework for the face mask detection. So in the face mask detection, we have divided our models into the two phases. First, train face mask detection model, and the second is the apply face mask detection model. So in the train face mask detection model, first we are loading the images, and after that we are doing the several augmentation, and after that we are training the model using the CNN model. And in the CNN model, we have tried with the three models. First, we have tried with the MobileNet V2 models, and after that we have tried with the YOLO V4 model, and after finally we have tried with the Inception 3 model. And in all the three models, we have seen that in the case of Inception V3, we get the best result. So we have considered for the classification, we will use the Inception V3 as our base model. After that, we have saved the classifier into the disk, and while applying the face mask detection model, we are loading the image, and then we are doing the face detection using the empty CNN, and again we are doing the data pre-processing. And after data pre-processing, we are loading the classifier, and finally we are classifying that person is with mask or without mask. So these are some of the sample results. So if the positive case is there, so this is the positive case when the person is with mask, then it is green label and it is saying 100%. And if negative case is there no mask, 100%. And these are some of the negative cases which I have taken. So even if the person is with the half mask, then our model is able to classify that with the person is no mask. And when the person is the group also, then our model is to classify all the person and says that no mask is there. And mixed cases, here we have taken where one people is with mask and one people with another mask, then we will see that it's classified correctly. And when in the group all the people are with mask, then also our model able to classify properly. And these are some of the test cases which are failed on the another models. So we have tried with the ladies with the face pack. So in case of MobileNet V2, this gives the positive result as the mask was there. But in case of Inception V3, we got the result as no mask is there. And even if the person sides her head, then also our model able to classify properly if the mask is there. And even we put our hands on the faces, then our model will be able to classify that it is without mask. So this is the model. And here the evaluation matrix which we have used is the precision, recall, F1 score, and the accuracy. And this is the training loss and the accuracy curve. So here we can see that the loss curve is gradually decreasing. So we can say that our model is not overfitting. And for taking care that whether our model is overfitting or not, we have also added the dropouts between the layers of the Inception V3. So we can get the accurate accuracy. And these are the three models which we have compared. So MobileNet V2, YOLO V4, and Inception V3. So in the same data set are used for all the threes. And in the case of Inception V3, we got the accuracy around 98%. And F1 score also 98%. And now we can see about the recognition model. So in the recognition model also we have divided into the two phases. First, the generation of the face embedding factor of the database, and second, the face recognition using the FaceNet model. So first we are taking the image data set, and after that we are doing the face detection using the HAR cascade, and then landmarks were generated, and that landmarks from we are extracting the features and we are sending into the FaceNet model, and that FaceNet models extracting 128-bit embedding vector, and that vector is saved in the database. And in the face recognition model, we are taking the image of the person with the mask, and after that we are using the HAR cascade for the face detection, and same we are using the facial landmarks and extracting the feature, and after that we are sending it to the FaceNet model, and we are taking the 128 embedding vectors from the here. And now we are comparing that the vectors which are present in the database and the vectors which we have generated now. Here we are using the triple loss function for whether that person is there or not for that. So this is the face recognition model. So these are the sample result of the face recognition model. So if the person is with mask also, then it is saying that Abhay is his name, and this person is with mask, then it is saying the Prasad. So here what's the problem is that around 128 embedding is generated, but above the mask only 20 to 22 embeddings were seen. So these have to classify from that 22 embeddings only. And these are the some more results, like if the Prasanna is there, Purvi, Pooja, and myself, Prashant. So these are the results which you obtained for the face recognition. And now what we have done, so we have generated a system like if the person is with mask, then only it will go for the recognition. And if the person is without mask, then it will not go for the recognition and it will say without mask. So here we will give the input image as a person image and it will go for the face mask detection. And if the person is without mask, then it will only, the result is without mask. And if the person is with mask, then it will go for the recognition model and it will give the result as person name and plus with mask. So that result we can see now. So if the person is without mask, then it will say simply without mask. And if the person is with mask, then here what we have done, that we have combined both face mask detection and face recognition combined, so that we can get the combined result. So here we will see that if the person is with mask, then here his name is also coming and the tag is also coming that with mask is there. Similarly, if here the Prasad and the with mask and the Purvi with mask. So these are the final results. So for the combined results, we cannot calculate the F1 score and all that thing. So we have tested for the 100 test images, and in 100 test images, we got around 88 images correctly. So we can say that for the combined model, we are getting the accuracy around 88%. And the conclusion is that we have proposed a framework for the detection and recognition a person with a mask on the face, and data set of 2,520 images of the 42 individuals was generated. And we have experimented with the 3 CNN models, MobileNet V2, YOLO V4, and Inception V3. And for face mask detection, we have obtained 98% accuracy. From all the model, Inception V3 is the best when we have compared that. And for the FaceNet model, we have used the face recognition model. And when we combine the Inception V3 model and the FaceNet model together to generate the result for the masked face recognition, we get the accuracy of 88%. And our future scope will be like we can use it for the attendance mechanism for the schools and for the airports and for all other places. So if the person is with mask only, then it will able to enter and their attendance will be taken. So these are the things we can do, and our models can further be fine-tuned in the accuracy of to recognize for the multiple faces. So now in the combined model, we have only implemented with the single faces. So in the future scope, we have tried with the multiple faces also. And these are some of the references.
Okay, thank you.
Yes.
See, for regarding this research work, what we have performed, there are a number of works which have been done on this. So,
Yes.
Why you have preferred CNN? There are neural network techniques which can give better result than CNN.
Yes. Yeah.
Then
so
why
CNN,
CNN?
in CNN, I have tried with the several, like CNN gives, I have tried with all the CNNs, it gives the better result, because I think for this type of detection, CNN prefers better apart from that. Because previously also I have worked for the some papers like in my research. So there also we have for the face detection, we have used the CNN only. So, and there we got the better result. So we thought of going through that. Yes.
Okay. Have
And
you compared
here we have
something
also
like,
taken.
Have you compared SVM with CNN? Have you compared
No,
the
we have
result
not
of
compared. We have
SVM?
only compared the different
Then
no,
how
that
you
we
can
can do in
go?
the future
How you
scope.
can go for a result? Yes, you speak out. Then I will.
Yeah, like
ask.
yeah. As of now, I have only compared with the several CNNs, and in that CNN, we got the best result with the Inception V3 model. And we have also take care of the overfitting cases, and we have changes different dropouts in between the layers of the CN of the FaceNet image, so that we can say that our model is not overfitting. All the things we have taken care while doing the experiments. And as of now, we have done only with the CNN. So in the future scope, we can try with the SBM, and we will see that if SBM and all that things gives the better result, then we can go through that in future.
Okay, fine. Thank you, Prashant.
Hello.
Thank you.
Yeah. Any more question?
Is the input is on a picture format, or is there a live stream will be there?
Yeah,
create the
for
data
the
set.
face detection, live streaming is also there. Yeah, we have created our own data set, and it also works on the real time also. It is not for the images only. If it works on the real time also, if we with the webcam we can open our face, then we are able to classify whether the person is with mask or without mask, and we can also get the label as my name, that if the my images are present in the database, then only. So if the images are present in the database, so it will compare with the images which it is taking from the real time, and it will compare with the embeddings using the triple loss function. And we will see, like it will compare. If it matches, then it will say that the our name will be there, and otherwise the name will be not there.
Name means name will be there,
like recognition, like when we are doing the recognition like we are putting the in the database with the name, whatever the name we are augmenting name here.
If there is,
Can you
if
understand?
there are, if in front of you 10 people are there and you never seen them, so how do the name will, how do the name will come? I mean,
then for recognition only work when their image will be in the database, because if it will not in the database, then how we can recognize that? Yeah, have you got it?
So there is a disadvantage of your work.
Yes.
Okay.
You can link the
for
data
the
set,
face
like
mask detection.
you can link some sort of data set, like Aadhaar data set and all that things, and then you can go for it. Can this algorithm work for a data set, huge data set of Aadhaar?
This work is already done.
Yes, it will work.
Yeah, it is done. That's what my question was to him.
Because I published a paper same on that.
Yeah.
Like
okay, fine.
Okay.
It was done.
Okay,
face
fine.
detection, face.
Yes. Okay, fine.
Okay, Prashant.
Yeah.
Now we have completed all our presentations. I sincerely thank our author for their excellent presentations in this session, and to all our participants for being a part of this international conference. Thank you so much, everyone. And I hope this session was informative enough. All the presenter would be getting digital certificates via email within 2 working days. Further, all the papers have already forwarded to the Springer. Kindly cooperate with the team of ICTCS, because the publication live within 6 months, 5 to 6 months. So be kindly cooperate with the team of ICTCS. And I also thank our chair of this session, Professor Nilesh Sable, sir. Thank you so much, sir, for being a part of this international conference. And this is a token of appreciation on behalf of Team ICTCS and the Global Knowledge Research Foundation.
Thank you, ma'am. Thank you so much.
And I just request to everyone, kindly please turn on their cameras to taking a quick snapshot.
Yeah, Richa ma'am, can you forward it to me?
Sure, sir. Sure, sir.
Okay.
Thank you so much, everyone. Stay safe and take care.
Thank you.
Thank you, ma'am.
Thank you, ma'am.